Hi, I'm Beth from My Tutoring Bee, and today we are going to continue our discussion about transformations and more specifically talk about dilations. So let's get started. So I have a simple box drawn here, a square drawn, graphed on a coordinate plane, and we are going to look at a couple of different ways that we might be asked to dilate this square. So the first thing that I wanted to cover is that whenever we're dilating and we're asked to use a scale factor of, when we see the word scale factor, that means multiply. You're always going to multiply by whatever that scale factor is. So if we are asked to use a scale factor of a number that's greater than 1, then our image is going to get larger. And if we're used to use a scale factor of a number smaller than 1, so something like a fraction or a decimal, then our image is going to get smaller. And I can actually show you kind of a little bit before we actually get into a real problem here of what a scale factor does. So I've got this pink square drawn here on my coordinate grid, and you can see that I can just shrink it down or expand it out. And that's exactly what's going to happen when we are asked to use a scale factor. Now, typically with scale factors, you are given a point with which to base your scale factoring around. In the examples that we're going to be doing today, we're going to base it around the origin, or 0.00. So if the point that we are basing our scale factor around is 0, 0. That's the origin right here in the middle here. So everything would either shrink or grow larger centered around that point. And we'll actually get into some examples to show you how this works. So I've given our quadrilateral, or our square, some labeled points here, E, F, G, H. So that is what the name of this quadrilateral is. And we have some directions here. Dilate the image of quadrilateral E, F, G, H using a scale factor of 2 and 0, 0 as the center of dilation. So we're going to first take a look at the coordinate pairs of each of these points of the vertices, the corners of the square. So let's take a look at that first. Let's start with F. What is F's coordinates? Well, its x coordinate is 2 and its y coordinate is 4. Over here with E, its x coordinate is -6 and its y coordinate is 4, +4. H's coordinate is -6, -4. And G's coordinate is 2, -4. Okay, so we've labeled all of the coordinates of each of these points, and that's important because when we are dilating the image, remember I said that we are multiplying, but what are we multiplying? What we're actually multiplying is the numbers that are in the coordinate pairs. So if we multiply each number by 2, then we will get our new coordinates for our image of EFGH. So let's go ahead and figure out what those coordinates are. For F, if we multiply 2 by 2, that gives us 4. And if we multiply 4 by 2, that gives us 8. So I'm going to place F prime. We use prime for the image, or the secondary version of each of our figures. So our new image is going to be right here at 4, 8, and that's going to be F prime. Okay, and then let's go over to E. We multiply each of these again by 2, so -6 times 2 is -12, and 4 times 2 is 8 again, so that's our new coordinates. Oops, I forgot my parentheses there. So -12, 8, let's see, I need one more label here. -12, 8 is going to be right here, so that's going to be E prime. For H, again, we're just multiplying, so then we should get -12, and -4 times 2 is -8. So that should be right here. You see I'm lining it up with the -12 on the x-axis and the -8 on the y-axis. So that's H prime. And then we have g, 2 times 2 is 4, negative 4 times 2 is negative 8. So we'll have our g prime at 4, negative 8. And then we can connect all of those. So you can see that we have now dilated this pink box into this teal colored box. It's gotten larger, and that's exactly what we would expect because 2 is greater than 1, so we would expect our image to be larger than the original version. And we've centered it around 0, 0, and here is our origin, 0, 0. So it's all centered around that point and expanding out from that point. Now let's take a look at another one. This time our scale factor is going to be less than 1. So if you take a look at our directions, dilate the image of quadrilateral EFGH using a scale factor of 1/2 and 0, 0 as the center of dilation. So everything is exactly the same as the last problem that we did, but instead of our scale factor being 2, now we are using 1/2. So we'll show you how that looks. So again, I've left my points here. We already identified all of the coordinates for F, E, G, and H. So let's go through and now multiply times 1/2. So multiplying by 1/2, that might sound like it doesn't make any sense, but really it's the same as dividing by 2, right? If we take half of something, we're dividing it into 2 pieces. So however you want to think of it, I'm going to write it as multiplying 1/2 for each of these. And since we have nice even numbers on all of these coordinates, it should be really easy to cut all of these numbers in half. So our new f prime is now going to be half of 2 is 1 and half of 4 is 2. So our new f prime is going to be at 1, 2. There's f prime right there. And then e prime is going to be half of negative 6 and half of 4. So half of negative 6 is negative 3. Half of 4 is 2. So our new e prime will be at negative 3, 2 right here. Prime. And then h, again, we're going to multiply by 1/2 on each of these. Half of negative 6 is negative 3. Half of negative 4 is negative 2. So we've got negative 3, negative 2 here. So that's h prime. And then with g, half of 2 is 1, and then half of negative 4 is negative 2. So g prime will be at 1, negative 2. So g prime be at 1, negative 2. And then again, we can just draw our straight lines to show that our box has been transformed. So let's try another one. This time we have a different figure graphed, and our directions now say dilate the image of triangle IJK using a scale factor of 1/3 and 0, 0 as the center of dilation. So I actually want you to pause the video here, see if you can label the coordinates, and then figure out what this dilation would look like with using a scale factor of 1/3. First, ask yourself, is it going to be larger? Is it going to be smaller? And what should you do with those numbers, with the numbers in the coordinate pairs? What will you do with those in order to find your new coordinates? Okay, so hopefully you paused the video and you've tried it out on your own. Let's see what this will look like when we actually use the scale factor of 1/3. So first we need to find the coordinates, right? So let's start with I. Its x value is negative 3. Its y value is 6. With j, its x value is 9. Its y value is positive 3. And with k, its x value is negative 6 and its y value is negative 6. So hopefully when you asked yourself, should this get larger or smaller, you said smaller because 1/3 is smaller than 1. Whenever we have a fractional amount, a fraction that's smaller than 1, then our image is going to shrink. So let's apply that to each of these numbers in the coordinates. So we're going to multiply everything times 1/3. Okay, so now let's do our calculations. 1/3 of negative 3, again, we can kind of think of this as just dividing by 3. So 1/3 of negative 3 is just going to be negative 1. And then 1/3 of 6 is going to be 2. So our new I prime will be at negative 1, 2, right here. I prime. 1/3 of 9, we're going over to J. 1/3 of 9 is 3. 1/3 of 3 is 1. So our new J prime will be at 3, 1. And then let's look at K. 1/3 of -6 is -2. 1/3 of -6 again is -2. So our K prime will be at -2, -2. And then we can connect these dots, and we see that we have a smaller version of our original triangle. I hope this video about dilations was helpful for you. Please don't forget to like and subscribe and comment below. Let me know how you're doing with your dilations. Thanks.